Hi, I'm going to show you how to do this session called regular expressions and grep. The outcomes of this sessions is that you can learn that there are multiple flavors of regular expressions. We'll be using some regular expression patterns. We'll use grep and its manual. We use the grep manual to search for these regular expressions and how to use it, and we can send the output of grep to a pipe. In the optional exercises you will see the flexibility of grep. Why do people use regular expressions and why are they useful? Well, in text there are a lot of things that have patterns. For example, a human name is a type of pattern. It starts with an uppercase character, never a number for example, and then it has typically lowercase characters. Some have a dash, some have a space, and after a space is not an uppercase character, but besides that it's usually lowercase characters. So we can describe how a name looks like. We can describe the pattern of the name, and this pattern can be written down as a regular expression. Also, a phone number typically starts with, for example, it has 10 digits, it has a dash somewhere. For international phone numbers it starts with plus or 00. We can describe how a phone number looks like, and phone numbers never have letters in them, for example. So that's a regular expression. And this is an overview. Like if you have any text, then grep filters that text using a regular expression to obtain the filtered text. That's the purpose, that we can say, hey, I want all the phone numbers, I want all the first names. So that is the purpose of regular expressions, to use text that has a pattern. Why do we use grep to do so? Well, grep comes installed with Linux, and grep is an abbreviation of the GNU regular expression parser. GNU is a group of people or an organization. A parser is a program that reads text and interprets it, does something with it. So what grep does, it's written by a group of people that made it read regular expressions and do something with it. Now it's time for the exercises. And we start with exercise 1, in which you're going to use the grep manual. Now for this, I'm going to put this at the left of my screen, and at the right I'm going to start a terminal. Exercise 1.1. View the grep manual. Tip man is the command to view a manual. Well, then it's man grep. There! We have the grep manual. Double check the answer. This is correct. We can use the arrow keys to navigate and Q to quit. Let's double check that. I click on the terminal, then go up and down with the arrows, and Q indeed to quit. Start again. Exercise 1.2. What does grep do? According to the grep manual in a one-liner, what does grep do? Tip, it's at the top. Here's the command grep name grep. It prints lines that match patterns. That's what grep does. And that's exactly the answer. Exercise 1.3. What are the other greps? In the fourth line of the grep manual, the grep-like tools egrep, fgrep, and rgrep are mentioned. Indeed, these are like 3 other grep-like tools. What are those? Tip, it's in the first 2 screens. First part of the answer can be found in the description section, that's already here. Second part of the answer can be found in options, pattern, syntax. Okay, let's take a look. So we need to look for the word egrep, fgrep, rgrep. There, egrep, fgrep, rgrep. They are the same as using grep with dash, capital E, dash, capital F, dash, lower R. Alright, so we need to remind this capital E, capital F, lower R. Now I need to look for the pattern syntax section there. Capital E, capital G, and capital P. Alright, well, it doesn't show the Perl thing, but sure. So capital E, it's a dialect. that the interpreted patterns are extended regular expressions. Well, we also have interpreted patterns as basic regular expressions. And there are also the Perl compatible regular expressions. So these tools do parse regular expressions but using a different dialect. We can conclude from this that the different greps have different types of regular expressions, such as regular, extended and Perl compatible regular expressions. So with that I have just showed you exercise 1. Now it's time to look at exercise 2. I'm going to quit this manual. Hi, I'm going to show you how to do exercise 2. Use grep with a pipe. Where we'll be using grep with a pipe. Exercise 2.1. Read a command that has a grep with a pipe. How would you explain the command below in English? Use some regular expression if you see a regular expression. Let's take a look. Here, man grep. I think this means show the grep manual and then forward it to grep using, I guess, some regular expression. Take a filter it for some regular expression. Well, now we're going to run this command, sure. There. I read from the title, run a command that has a grep with a pipe. Run the command above. What does it show on screen? What did the regular expression do? Let's take a look. I'm running it. I see some stuff here. That looks like warnings to me. No idea what it means. But besides that, I see some red letters that are always showing up at the start of a line. For example, here's also like a cap. They're always capitals. So I guess it filters for the lines that start with a capital. And this is useful to find the chapters. Let's take a look. So this person did not have like all these warnings here. It shows all lines that start with an uppercase character. So with that, I have completed exercise 2. Hi, I'm going to show you how to do exercise 3, practice regular expressions. And for this we need to go to this website and do lessons 1, 2 and including 11. Let's do it. So I put this on full screen because this website shows you some regular expression patterns. And the most important thing, or there's like a chart here that shows you how to describe things. For example, to describe a range, characters A to Z, you use like these square brackets A-Z. So this is the things you'll be practicing, but it will also be in this text too. So here we have 3 lines of code of text, it's ABC. This is how you would match, how you would filter for these 3 things. Now we're going to use digits. Well, that's just the same thing, 1, 2, 3. I see them everywhere there. Now we're going to use the dot. So the dot can match any single character. Sure, let's do that. Dot, dot, dot. But it must not match this thing. So it must be also a real dot at the end. So if I do a dot, well, a 1 and a dot are both any type of characters, but I need to escape this dot. This means an actual dot. And now I select all 3 things. Matching specific characters using this pattern. Well, so I use this pattern. I guess they all have an N, and then it should be CMF. There. So this means that I don't include D, R, and P. Now we're going to exclude specific characters using this thing. So it means not ABC. So we have OG, but that must not be B. There, not B, OG. Next are character ranges, like this or this. Let's take a look what the character range are. So here we see all capitals, A to Z, and then we have like two anythings. Good. Catching some Z's using this selector. So we see that there are 3, 4 or 5 C's. So let's say, well, at least 3. 3 would work. I would say 3 to 5 would work. 2 to 5 Z's would work, as long as it's more than 1. Yeah, so this would also work. Now we're going to use the clean star and the clean plus. So the plus means once or more, where the star means 0 times or more. So it all has an A, and it can be anything forever. And we could also do like this will still match with this, because nothing also matches this, because it must be any character at least 0 times. So we can say, well, we do use 2 A's, you can do that. You can also say, well, it needs to have an A and then one or more A's, and then we're going to use everything, for example. So these are the clean star, the clean star, and the clean plus. Exercise 8, optional characters. So this means a character that may or may not be there. So let's take a look. We have file and file, so there will be file and then maybe an S. So now we've matched the word. And then at the end it should be a question mark dot star question mark, which should be real question mark, this one. Good. And I think even if I remove this part it will still work. Yeah. All this white space. So we're going to use \s, which will match any of the specific white space above. Right, so we use \s to have some white space. I see there's a dot at the start. Let's add like a digit. We can use like this, 0 to 9, a dot, any amount of white space, and then ABC. The problem is that some white spaces are longer, so it needs to be at least one white space. So that's a plus, and now we match everything. Starting and ending, and that's with a hat and a $sign. So here we have a line that starts with mission. Well, and then we put a hat there. The last exercise here is to match groups. So we're gonna capture things using round braces, and this is useful for replacing or extracting things. Let's take a look. PDF, PDF. So it should end with PDF, or it should have PDF on it. But we must capture the thing before. So we want to capture the file name. Let's do .star to get everything in front of it. Let's put a round brace around this. Now we capture things. And if you put a dot, which means any character, now we capture what we need. Like better would be this should be a dot, so let's make it like this. It's more strict, but this also works. I do see that there's a problem here. Apparently it's not good enough. Let's take a look. It needs to start with file, sure, file. There. It needs to have the extension PDF, sure, there. It needs to start with file, sure, now we add it like this. Okay, and now it still works just as good. So these were the exercises 3. Hi, I'm going to show you how to do the optional exercise 4, which is titled Can grep do? And I'll just go through them, and I already put this thing at the left, this window there. I'm going to put a terminal at the right of my screen. Can grep do a case-insensitive search? Yes, it can. Use the grep manual to answer this question. So I'm going to do man grep to look at the manual. And we're going to look for case-insensitive matches. So it's not a pattern syntax, maybe that's it. Matching control, sounds good. Ignore case. So yes, with this flag I can do this. And that's the answer. Can grep show the lines that do not match? I guess so, with invert match. Yeah, it was just on the screen. So. Can grep detect lines in multiple files? Alright, so this is not matching control. This is like a file selector. Let's scroll for general output control. That's not it. Output line prefix, whatever that is. Context line control, no, skip. File and directory selection, that's a good one. Can it detect lines in multiple files? So binary file, devices, directories, no idea what this is. Exclude or needed, exclude from, exclude dir -e, include. It's probably to select the recursive. Read all files under each directory recursively. Note there's a similar thing here, called also dereference recursive, where this one follows all symbolic links, and this one only does so sometimes. So yes, grep can detect lines in multiple files using the recursive flag. And to give an example, let's just run this. cd etc. This is a folder that has a lot of useful things in it. And we're going to look for the pattern Ubuntu. And here we see all files in all these folders, in this folder and its subfolders that match the expression Ubuntu. Can grep detect which files contain a match? So now we've seen the matches themselves, but if we only want those file names, so this is the file name, can we also get only the file names? Well, for that to go back to the manual, I'm going to take a look at how it's outputted. Pattern syntax is not it. Matching controls, it's good. General output control, maybe it's there. Files with matches. Suppress normal, it says print the name of each digit. Maybe it's this one, files with matches. Try it out. There, and we have all the files that matched. That had the regular expression we were looking for. But this only shows the file names. So this is wrong. This is not it. We're not only looking for the file names, we want to look for the people, the matches in the files. So this was wrong. Where were we? Only matching. No, that's not it. Only matching. Output line prefix control. No file name with file name. Line number null. Context line groups. Selection. That's good. We look for recursive. We probably want some output. Other options. Or I missed it somewhere. Let's go up again. Extended matching controls. Pattern, file, ignore case, ignore invert match. Line regex, count, color. Files with match. Only matching, no messages. No file name labels. Line number, initial tab, null. Group separator. Let's take a look what the file with matches. Maybe the order matters. Files with matches. There. Let's do some other regular expression like AB. Alright, it was correct what I did. I was just thrown off guard by that all the files also having Ubuntu in the file name themselves. But if I look for the regular expression pattern AB, I see there's a file called hosts that contains the text AB. So this worked perfectly. Next question. Can grep detect which files with a certain extension contain a match? Let's take a look. The answer is yes. Man grep. So we're going to only look for a certain type of files. Pattern syntax, matching controls, general output control, output line, it's like file selection or something. Context line control, nope. File and directory selection, this seems it. Action, exclude from, there. Include is glob. So glob is not a regular expression pattern, it's a simpler one. Include is, and then glob star.conf, for example. And now I see the matching files that all have conf as their extension. And what is the actual pattern AB? Well, I can put this back to Ubuntu. So now I see all the config files that have the word Ubuntu in their content. So with this, I have just done exercise 4. Now I will ask some harder, high-level questions to both repeat and learn a bit of new things. How many regular expression dialects do exist? Well, we've seen in the manual that there were multiple flavors, like the regular, extended and Perl-like, so that's at least 3. We have sent the grep manual to grep using a pipe. Can we use any text? The answer is yes, we can definitely send any text to grep. Can we send the output of grep to grep? Absolutely we can, because the output of grep is just text. What is a clean star and what does it do? So it's simply an asterisk, and it means in a pattern that the thing in front of it must be repeated 0, once or more often. The thing before it repeats at least 0 times, so it's quite flexible. What's the difference between this and this? So this hat is placed outside of these selecting or inside. Well, the hat in this context means match at the start of the line, and then it must be an uppercase character. Where this matches anything that is not an uppercase character. This can be at the start or somewhere, as long if the line contains a lowercase character, for example, this will work. If a line only contains uppercase characters, this will fail. Next question. What is the regular expression for any line of text including empty one? Well, this means you need to have at least 0 amounts of any character. Any character is represented by a dot. So a dot means any character. And then we have the clean star again, which means repeated at least 0 times. And if you combine them like this, you have the all-powerful command that can select everything including nothing. Next question. Why does this not work where this does? So the only difference here is the quotes. This works because here grep gets this string, gets the text dot star as text, and then it will parse it, it will read it and do stuff with it. If you use dot star like this, it's not grep working on it, it will be bash, it will be the terminal listing all the hidden files. And then grep has no idea what to do with all those hidden files. The last question is, well, if you know that the grep ignore case is used to ignore the case, and the grep -- invert match inverts the match, how do you combine these in the same command? The answer is put these behind each other, looking like this. And this means with this I have gone through the extra feedback questions. Hi, I will round off this session about grep. So grep is useful for pattern matching. It's what it's made for. It has a useful manual with a lot of options. It's a filter. It will always produce less text than you give to it. It works well with pipes. Send text to it, it will work. We have seen that there are multiple regular expression dialects, like the regular one, the extended one, and the Perl-like one, whatever those are. If we want to match a character, a set of character, or not a character, or not a set of characters, we use a dot, this thing or this thing. A dot means a character. Between these square brackets you put a range, for example 0-9 or capital A dash capital Z. And this is to mean not. For example, you put in the hat and then a capital A, it means not A, between the square braces. If we want to indicate an amount, we use the star, which means at least 0 times, the plus at least 1 time, question mark 0 or once, and the number between these curly braces is how often the thing in front of it should be repeated. If we want to capture something, for example the file name without the file extension, we can use these round braces. And besides that, we found that grep can do a lot of different things. From this conclusion about the next sessions in this course is a drawback of grep, or a feature of grep. It's not a programming language. Sure, it can parse regular expressions, it can filter on it, but it's not Turing complete. If you need something more powerful, use awk, which is a programming language instead.